Hey everybody, just want to do a little video on average rate of change questions, some tools that you might consider using. Of course, probably have a graphing calculator, and it's a little harder to show you online how to use that, but happy to support you if you do have one on using those tools. I pulled up a question in that first section. I think it's something like question 11, where, let me just share my screen here. Something like this, where you are calculating the average velocity for this position. So we're looking at how did the position change divided by how did the time change. And then we're going to kind of go from there and figure out how, as we narrow that interval down, what happens to average velocity, and can we make a prediction about where it's going to end up. Now, I'm not going to do this question because you may get this question, you may get something similar. I think they just changed these numbers around. But I made it my own question, and I wanted to look at a picture of it because this is this is a graph of something similar, a quadratic downward facing. And I'm going to go ahead and annotate a little bit. So I call this f of x, they call it s of t, where the y-axis is the position and the x-axis is the time. So for instance, if we were kind of interested in what's happening between 1 second and 2 seconds, just to kind of follow with their example. If we go back and look at the table, we're going to end up plugging in values for 1, 2, 1.5, 1.1, 1.01, and 1.001. So I'm going to just make that table right here. 1, and I'm going to put them in order of size, not in order of what we would explore it as. So we're going to look at the interval between these, and the interval between these, and the interval between these, and the interval between these. And on this picture, S of t is here, S of 1 is here, which is, in my case, f of 1. And f of 2 is going to be somewhere down there. I can't even see it right now. 1.5 is going to be somewhere like here. 1.1 is going to be somewhere like here. And then 1.01. Oh, actually, that's not 1.1, that's 1.01. So those values are going to be much closer down in there. I'm going to change this just because I made a mistake. I'm going to change that to 1.1. My eraser. One. And then we can kind of look at 1.01 and 1.001. So it is nice to use your technology to be able to plug in values here. I might use something like Excel to just plug things in because I use Excel a lot, and it's the table version of this is a nice way to look at it. So if you don't know how to use the table functionality on your calculator, let me know. But basically I have my input, I have my output, 1, 1.01, 1.1, 1.5, 2. Then I want to look at the interval between 1 and 2. Average rate of change. What I need to do in order to figure that out is let's go back to what was my value here, negative 18 times this number squared plus 30 times this number. Okay, so it's 12. Let me just double check that makes sense. Yeah, that's right. when I have a value of 1, I get an output of 12. Perfect. Okay, so when I put in 2, I'm going to end up negative. But with Excel, I can use autofill. With your graphing calculator, you have to change the inputs in order for you to be able to say what the independent variable is. But beyond that, it'll just generate automatic. It should generate automatically the outputs for you. So let's just consider, what happened here between 12 and minus 12. So the average rate of change, if we take the output of F2 minus F1 divided by 2 minus 1, that ratio, put some spaces in here and see if I can fool them into not making this February. Okay, good. So that's going to be minus 12 minus 12, which is negative 24 over 1. So my first average rate of change is going to be negative 24. The next rate of change, going from 1 to 1.5, is going to be f of 1.5 minus f1 over 1.5 minus 1. So I'm looking at 4.5 minus 12, which is negative 7.5, but I'm dividing it by 0.5. So the end result of that is that the average rate of change, let me just kind of clean this up here, for the next interval is negative 15. Okay, and then I can do the same thing for the next one. Clear off my annotations. I'm just going to copy and paste that. So now I'm going down to 1.1. So this time I've got 11.22 minus 12. So still a negative number on top, but a pretty small one. And the difference between 1.1 and 1 is 0.1. And so now my average rate of change is looking like negative 7.8. So it's dropping here. We started off with negative 24, then we have negative 15, now we have negative 7.8. Let's go one more. From 1 to 1.01. I'll go ahead and copy this again. I just got to stick in some zeros. And so this value is going to be really small because now these numbers are getting very close together, but I'm also dividing by a very small number because 1.01 and 1 are very close together. Negative 6.18. And if I went another iteration, and I think that's probably why they went all the way down to, oh yeah, they did 1.1, 1.01, and 1.001. Then it's probably going to become more clear. Like my guess is going to be more clear here at the end. So just to speak graphically about what's happening, right? We're taking, I'm going to use lines instead of that. So we're trying to find out the instantaneous rate of change at 1. We're kind of approximating it with these are called secant lines. And we're slowly bringing that second point back closer and closer so that eventually we're creating a pretty good estimate, and I'm going to use a different color, of the tangent line, which is only touching 1 at one point. That's actually a pretty bad drawing. That would be better. Right, so these secant lines are slowly getting closer and closer to the real slope of this line, which is what I'm trying to find when I find the derivative. And that's really where we start our work in calculus. So just wanted to remind you that I think that it's important that this is not just a mechanical thing, but that you're kind of making sense out of what you're calculating and what you're doing. If you're having trouble with anything, let me know. I'm here to help. Don't be shy about reaching out to me and saying I'm confused about this lesson. I did do a live meeting on Friday, and I plan to do another one this Friday. I need to post that video, so if you missed it, you can go back and look. We didn't talk about any math. We just talked about the course and how things work, but people had some good questions. So, all right, hope you're doing well. We're halfway through the first week. Remember, you got some due dates coming up on Tuesday, so keep working hard. Let me know if you're having trouble. Okay, bye.